Welcome back to Inclusive Design 24 2023, brought to you in partnership with our Platinum supporters, Google and Intopia, and our Gold supporters, Barrier Break and Tetralogical. You can follow us on Mastodon, and if you have questions for the presenter, post them using the ID24 hashtag or post them in the YouTube chat for a Q&A if we have time at the end of the session. Reminder that ID24 is a respectful community. You can find our code of conduct on the Inclusive Design 24 website. Thank you for your patience waiting for us to join. I'm delighted to be joined here by Johan. Your turn.
Right. Well, next up is Leonie Watson. I don't know if Leonie needs an introduction because he's been sharing her knowledge on digital accessibility and inclusive design all over the world. And of course, he's part of the Inclusive Design 24 organization. And today he's going to tell us how we can up our game when it comes to voice experiences in our talk, Voice of Contention. Over to you, Leonie.
Thanks, Johan. Thanks, Adrian. Hello, everybody. And sorry for the delay. Technology troubles struck once again. As Johan said, I'm going to talk a bit about voice design. And I'm going to start off with a slide that shows a very simple word. Hello. And in the perhaps 300 milliseconds it took me to say hello to you all just then, you started to form opinions about the speaker whose voice you could hear. Probably that I'm British and that I'm a woman. You'd be correct on both counts. What's really interesting is that we process audio about 100 times faster than we process visual information. So if I didn't have my camera switched off at the moment, you'd be processing the sound of my voice faster than the look of my picture. And that's really remarkable because it tells us that in someone's voice, we get a whole ton of information about the speaker, about who they are, perhaps given the content, the words they're speaking, we might also understand something about what they're talking about, whether it's scientific, informal, bit of a chat, a lecture somewhere. All of those things happen through somebody's voice. And I think that's quite remarkable. And of course, today we have all sorts of talking technology, our watches, our TVs, our laptops, our phones, of course, and our tablets. Pretty much everything, home assistant devices, has the capacity to talk to us. But there are two gaps in that. One is browsers and the other is screen readers. Well, actually, that's not quite true. Both of them can talk to us, but the gap is that they pretty much sound the same old boring thing, no matter what they're talking about. And that's really what I'd like to focus on today. And to do that, I'd like to go right back to my next slide and speaking clocks. Now, these might not be the first thing that you think about when it comes to voice interfaces. But part of my argument for wanting a way to let us as content creators design the way spoken content sounds, both in the browser and for screen readers, is that we've been doing it for a really long time. And actually, we've been doing it really well for pretty much all that time. And speaking clocks are a really good first example. So there's three kind of components to this. The first is speaking clock architecture. I always thought, that for a longest time, there was somebody on the end of the phone when I called the speaking clock. Turns out that was never the case. Even if we go back to the 1930s when speaking clocks were introduced in France first, then UK, Canada, all sorts of countries, it was done through an automated system. And the architecture, my next slide, is a set of 4 glass discs. At least this is how it was in the UK. And each of those discs had a small amount of information recorded. One kept the hours, one kept the minutes, one kept the seconds, and the other kept a couple of keywords that could be slotted in to make sense of the content. So right from the beginning in the 1930s, 90 years ago, this was a fully automated system. We then come on to the next part, which is quality, the quality of the voices that are used. And the speaking clock in the UK is a really interesting example. The very first person who comes up on my next slide, who was the speaking clock in the UK, goes by the name of Ethel Jane Kane. And here she is giving her speaking clock rendition.
At the third stroke, it will be 11:25 precisely.
And then if we move on, we hear Pat Simmons. Now, Pat Simmons took over being the speaking clock in the 1960s, and it was still using the glass disc technology. So although the quality of the voice sounds similar, it has moved a little bit with the times if we listen now.
At the third stroke, it will be 8:57 precisely.
And so they both sound, very elocuted, very precise, very of their time. But if we move on to the next slide, and Brian Kobe, we move in two different directions. One into the 1980s, and that's the time that the speaking clock became digitized, so a digital voice interface as we might understand it today. It was also the first male-gendered speaker of the clock, and the quality of his voice also changes to become a little bit less buttoned up, shall we say. Let's listen.
At the third stroke, it will be 9:59 and 20 seconds.
And then finally, we move on to Sarah Mendes da Costa, who became the voice of the speaking clock in the early 2000s. And Sarah has a much more approachable voice, for want of a better word. So if we listen now, you can hear just how much more modern she sounds.
At the third stroke, it will be 2:43 and 20 seconds.
So the quality of the voice changed through time and through technology. And that brings us on to the final piece of the puzzle, which is content. And in terms of the content, you've heard all those messages already. They're very simple. They just tell you what the time is. But this is where the keywords come in. So on the next slide, we've got the precisely bit. So if the time is, very precise, i.e. there are no seconds involved, we can hear what the message sounds like.
At the third stroke, the time will be 6:45 precisely.
And that precisely after the beeps told you exactly that. If we head on over to the next slide, we hear the different content that's spoken if the time involves a number of seconds, like this.
At the third stroke, the time will be 1:58 and 10 seconds.
So we had good architecture, good quality of voice that moved, in this case, through the times, and good content design, good choice of words that really made a very effective and enduring voice interface. But let's get ourselves out of the past and into the current times, and Home Assistant devices, one of the most prevalent voice interfaces that we all experience today. If we look on the next slide at the architecture, and move on again, we can see that this really all happens in the cloud. And this is a really important feature of this, because in the cloud, we have access to a lot more processing capability. So it means a huge step up in terms of the architecture. It's much more complex, much more advanced, but also the other aspects like the quality of the voice, for example. So as we move through the next few slides, there's a couple of different text-to-speech examples I'm going to play for you. The first is neural text-to-speech engines.
Neural TTS uses artificial neural networks trained on huge amounts of voice data. The neural networks learn the relationships between text and speech, and the result is voices that sound very close to human speech.
And that neural TTS is, as it just explained for itself, remarkably human quality sounding voice. When the next slide gets loaded up, you're going to hear a cloned voice clip, which neural TTS makes possible, like this.
Neural TTS can transfer the prosodic characteristics of one voice to another, making it possible to synthesize speech in the voice of a particular speaker.
And what's really remarkable about that is it took about 10 minutes of me training that system in order to produce that example, which is not me speaking live. That's an entirely synthetic neural TTS-based clone of my voice, which is somewhat terrifying and somewhat astonishing all in one go. So the quality of the voice in Home Assistants both is extraordinarily good and has the potential to really range and become quite personalized, literally, if you choose to make it so. But let's move on to the content design and see what changes there. All of Home Assistants can be content designed to sound different using something called speech synthesis markup language, or SSML. It's a series of elements, very much like HTML, that can let you change things like the speed, pitch, volume, and other characteristics of the speech. And they're all very gentle, and they add a lot of richness to the experience of listening to your Home Assistant devices. If we move on to the next slide, it has 3 different sound examples attached to it. If we listen to the first one, it's Alexa just saying the simple phrase, "I'm so excited and I just can't hide it."
I'm so excited and I just can't hide it.
But because of SSML, Alexa can be made to sound a little bit different, perhaps to say the same phrase as though she really meant it, like this.
I'm so excited and I just can't hide it.
Or a little bit sardonically, like she's not really that excited, like this.
I'm so excited and I just can't hide it.
So with just a bit of SSML, the tone and quality of the voice kind of changed in very subtle, but really quite, important ways. If we move on again, we know that Alexa also uses this to produce different voice profiles. If you live in the US, she can be required to sound like a newscaster, like this.
This just in. Alexa can now deliver the news like a professional newscaster. The newscaster voice emphasizes specific words and phrases for a more compelling delivery of the news. The changes in the news delivery are subtle, but it is easier to tell when a sentence ends or when Alexa is reading a headline.
So again, as that says, just with subtle, gentle changes, nothing extreme, nothing hijacking your experience, it sounds, well, a little bit more like a newscaster. If we move on again, we find another feature that the Echo devices have, and that's adaptive behavior. If you whisper to your Alexa, it'll whisper back to you, perhaps like this.
Shh, be very, very quiet.
So again, listening and adapting to the environment in terms of the voice experience is something, that is very possible right now. So on Home Assistant devices, we have this wealth of features, this ability to design content, and this ability is actually open to anyone who produces content, who produces skills for Alexa. It's the same for Google Home, Google Assistant. All of these have the same capabilities for design. And in my experience, at least, we don't really get bad voice quality interface design problems, not in the way we do perhaps on the web, where color contrast or layout or text size might get in the way. Generally speaking, my feeling is that voice design is actually pretty good. So let's move on to my real purpose for this talk, and that of assistive technologies. And we'll go back again to look at the architecture. This time, of course, most of the architecture exists on the device. This is the same for web readers and for web readers in the browser, and for screen readers. I've spoken a lot about web reader speech capability in other times and places. So now I'm really going to focus in on the screen reader experience. If we move on, and we'll talk about the quality. Again, we come back to that same idea of the different text-to-speech engines, but because screen readers process information locally on your own device, they don't have access to the cloud, so the speech quality isn't really as good. The next slide, when it loads, will play you one of the most basic sorts of text-to-speech synthesis available to screen readers, formant synthesis.
Formant synthesis is rule-based. The acoustic characters of speech are extracted from a voice recording, then programmed as rules for recreating the voice as digital audio.
So as you can hear, that's pretty robotic. It's not very human. It does have the advantage of being remarkably performant, though. As a screen reader user, I listen to content on average at about 550 words a minute. For context, you probably have a conversation at about 150 words a minute, give or take. So for me, at least, the trade-off is kind of rubbish quality against the ability to listen and use my technology fast. But on the next slide, when it loads, we can hear an example of a slightly better quality TTS known as parametric TTS.
Concatenated synthesis uses a voice recording that's broken down into tiny chunks. The chunks are then reconstructed from a database to form the synthesized speech.
And these actually begin life as a human recording. Some poor soul sits in a lab for hours and hours at a time recording their voice, and it all gets broken down and then schmoozed back together, or concatenated, to use its proper term, into the words and sentences the screen reader needs to speak. You might think this would be really good for human quality of sound, but it really isn't. And the simple reason is that we can't ask a human to sit in a lab recording their voice until they've captured every possible nuance, every emotion, every rise in pitch, absolutely every aspect of human conversation that's possible. So although it's more natural sounding, it still has a kind of stilted tone to it. The best kind of TTS we get, if I get my names right this time on screen readers, is known as parametric TTS, like this.
Parametric synthesis uses a statistical model. The parameters of speech are extracted from a voice recording, then hidden Markov models, HMM, modify the parameters based on the text to be spoken.
So it's not bad in terms of quality. It's not quite as good as we get when things are processed in the cloud like for home devices, but it's okay, which takes us on to the next important bit, back to the content design. And here I want to focus on some words. One of the problems that text-to-speech engines have, and it's important to note here that the text-to-speech engine is not the same thing as the screen reader. Any given screen reader can work with multiple different text-to-speech engines. And in this context, at least, that's quite an important distinction to make. But on the screen, you can see a bit of text that says, I read a good book last week. I'd like to read it again someday. And with one text-to-speech engine, this is how it sounds.
I read a good book last week. I'd like to read it again someday.
So it got it pretty right. American accent, female voice, and the read and read were correct. If we move on to the next slide, we see another text example. This time, somebody gave me flowers tied in a bow as I took a bow on stage. But here's what the screen reader, or the text-to-speech engine the screen reader is using, makes of it this time.
Someone gave me flowers tied with a bow as I took a bow on stage.
So again, we didn't hear the correct pronunciation there, which is, well, a bit of a shame. Screen reader users, we get used to this, of course, but wouldn't it be nice not to have to? Numbers get even more interesting if we move on to the next slide. And you'll see, if you can see the screen, a series of numbers that might be familiar to you, especially if you use the WCAG guidelines. 1.4.8, 1.4.9, and 1.4.10. What could possibly go wrong with that? Well, listen to this.
1, 4, 8. 1, 4, 9. January 4th, 2010.
So instead of getting the last number in the series, we get a date, because this text-to-speech engine in the American voice thinks it's, well, a date at some point in 2010. What gets worse, though, is if we move on to the next slide, we can hear exactly the same text sequence read by exactly the same text-to-speech engine, only this time with a British accent. Listen to this.
1, 4, 8. 1, 4, 9. The 1st of April, 2010.
So again, the same thing happens because US and UK accents, or people, read dates differently. They don't even agree on the date in question. Is it the 4th of January or the 1st of April? Either way, you'll agree it's a bit of a pickle. So what can we do about this? Well, the solution doesn't really exist, but I'd like it to. And it comes in the form of a W3C standard known as CSS Speech. This has actually been around for about 20 odd years, but it's never really gained any traction. It isn't implemented in browsers. It's not therefore supported by any screen readers in browsers either. And I think that's a bit of a shame. So I'd like to share with you some of the things that I think it could do and ways that I think it could make screen readers a little bit more interesting to listen to. On the next slide, we've got the basic property of CSS Speech, and that's the speak property. And this simply defines whether something should be spoken or not. For screen readers, there isn't probably a strong use case for this particular property. But if I flip back to the idea of a web reader and something that doesn't speak any of the navigation, the header, the footer of a page, and only speaks the content, then using the speak set to no or not, would be a really good example. You can also, if it were implemented, associate this with the display property. So if display is set to none and speak is set to auto, it'll automatically reflect the display none and set itself to not speak. So if something's hidden visually, in other words, it can also be very easily not made available to screen readers or web readers, of course. The next slide shows a property called voice family. If you're familiar with CSS, font family, of course, will be recognizable to you. This is exactly the same. It just lets you choose the voice you want your content to be spoken in instead of the font you want it to be typed in. And I think this is really interesting because it could mean you could use different voices for different style of content. Again, going back to that idea of the voice profiles on Alexa. If you wanted your news articles spoken more like a newsreader and your gossip magazines to be spoken in a more lively and formal voice, in theory, we should be able to do that. What's really interesting, if we head to the next slide, is that this is actually available in screen readers, or at least one screen reader already. JAWS has a sound theme called Rent-A-Crowd. It only works with its very basic eloquence text-to-speech engine, so that's the kind of Formant TTS quality we heard earlier. But here's what it does. Listen up.
Nothing happened.
Visited King Leonie Watson on technology, food and life in a digital age.
News headline, nothing happened. Saturday, 1 April 2023. Absolutely nothing happened today. Everybody went and had a nice cup of tea instead.
Now, this is a really crude example using a not very good quality TTS, but you get the idea. There's just some gentle changes that increase the pitch, lower the tone, change the volume a little bit, just to give the whole thing a bit more texture than listening to everything in exactly the same voice at exactly the same speed. And I think that's an idea worth considering. If we move on again, we get a number of different properties known as the prosody properties. Prosody is the linguistic term for changing things like volume and speaking rate and pitch. And you can do exactly that. You can change the volume, you can change the pitch, and you can change the rate of speaking. Normal's the default, but you can change them by increments to be a little bit louder, a little bit faster, or a little bit faster again, or the reverse. So these are incremental changes. They're not supposed to be scary. They're not supposed to hijack your experience. They're just supposed to be, based on whatever your current volume, your current speed, your current pitch is set to, and then just incrementally change them in different directions. Again, if we move on to the next slide, we can see that screen readers are already doing this. Most screen readers use a change in pitch to indicate the difference between a capital letter and a lowercase letter. So if text is spoken in all caps, it's spoken at a higher pitch, like this.
I, F, space, T, E, X, T, space, I, S, space, I, N, space, C, A, P, S, period.
And that's a really nice user experience. Takes a little bit of getting your ears used to it, but once you do, it's much more convenient just to listen out for a change in pitch than it is to hear, say, the word caps before everything that is a capital letter. There's another slide on the next example, and this is spelling rate. Screen readers, most of them at least, have the ability to be told to spell out the word that has focus. And when they do that, most of them slow down their speaking rate, like this.
Words are spelled more slowly than they are spoken. W-O-R-D-S space A-R-E space S-P-E. So
again, these are techniques that screen readers are using. I'd just like to see them made available more widely, so all content has that capability. If we move on again, we can also look at emphasis properties, ways to put a little more meaning or emphasis onto a word, because that's what we do when we're speaking as humans. We can put a stress on a particular word if you want to make a point, or you can change the kind of the voice range. This will lower the voice or just make it a little bit more emphatic if you need to, as I say, emphasize, make a point. Next up, we've got some pause properties, because of course, pausing is something we do in speech, maybe for dramatic effect, maybe just to, really get the listener's attention. But why not have the same ability to let web readers and screen readers do the same? So pause before, pause after, just lets you build in an incremental pause there too. And then we move on to one that's particularly, perhaps, controversial, the speak as property. Now, everybody who's been in accessibility, many of you will be familiar with this, at some time or another, at least once a week, get asked, how do I make a screen reader say something like this? Now, my default response is don't. I mentioned earlier, screen reader users are generally quite happy to deal with the kind of peculiarities of pronunciation, and you can often tie yourselves in real knots trying to get a screen reader to say something. The problem is that people do this. They have good intentions. They're trying to help. Right now, though, every single solution that you use to try and get a screen reader to say something in the right way causes problems for somebody else, somebody who's using Braille with their screen reader. For example, if you use a hidden text, you might find problems for someone using their own style sheets. If you use, say, the ARIA label, and then you put in things like the word dot, D-O-T, between an acronym, so you have, I don't know, H.M.T.L, things like that, you'll cause problems for speech recognition people. All the solutions are really ugly. So if we assume that people are going to try and do this anyway, the speak as property would actually give us a pretty nice solution for doing it, because it would literally target speech output and absolutely nothing else. It wouldn't interfere with anybody else's experience. And that's actually not a bad idea. So what if all this comes to pass? And if you're a screen reader user, I can imagine you're sitting there going, yeah, but I still don't want everybody to be able to design my voice experience for me. I like my screen reader the way it is. Just leave it the hell alone. Thank you. And that's why on the next slide, we have the idea of an override at the OS level. We've got this for animated content right now. If you don't want things to move and wiggle around, you can choose to opt out in your OS level settings. I think we need something like that for don't touch my voice experience, basically. Just whatever it is, web reader, screen reader, leave it alone. It's fine the way it is. So that's a conversation we need to have. Moving on, we also need to make sure that the CSS spec itself only has relative values. I mentioned earlier that you can change, say, volume to be loud, louder, or soft or softer. And that's fine. Those are incremental changes relative to the user settings. At the moment in the spec, in theory, it is possible to do things like set the volume to a particular decibel level. I think that would be a lousy idea, and we should get rid of it out of the spec. But that's to come in the future. And why do I want to do this? Well, on the next slide, quite simply because I think it offers screen reader users the potential for a better UX. If we go back to that news example we saw before, how about it sounding like this?
News headline: Nothing happened. Saturday, 1 April 2023. Absolutely nothing happened today. Everybody went and had a nice cup of tea instead.
So just again, some gentle changes that make the content much more rich and much more, I think, engaging and interesting. And that's a huge potential for this. The problem with all of this is that so far, browser vendors don't seem to appreciate the potential that we've got for this, both for web readers and screen reader users. And I've been doing my best to try and encourage them that this is a bit of a big gap in the web platform, and it's only going to get worse if the web is the only place where we can't design voice interfaces. But I'll let you into a little secret. The reason I'm really interested in this, and the reason why on this last slide there's a picture of Jean-Luc Picard, is because the whole reason I'm on this mission is because one day in my future, I just want my email to be read by the captain of the Starship Enterprise. And on that note, thank you very much.
Leonie, that was spectacular. I appreciate that you moved at speed to make up for some lost time. Johan, did you see anything come in?
Yes, I saw things coming in, no questions, but the chat has been very informative for me because I learned that apparently Time was sponsored by a company called Accurist. Well, I advise you to read it back so you will learn a thing or two. And someone was trying to start a debate on date formats, but it failed. No questions at all. So I think that's actually good. So we can make up some lost time. But thank you very much. It was a really great talk again.
Oh, you're very welcome. Thank you. And I should also give my thanks to Patrick, who was with astonishing agility, actually making the slides work, doing the sharing of sound. So thanks, Pat.
Kudos
No problem.
to Pat. Slide wrangler.
I think I messed up apparently, but I blame PowerPoint. It started sharing the edit view rather than the other view, but we'll fix it in post, as Adrian aptly put it in the chat.
It's all good.
always
Thanks,
good
Will.
to blame PowerPoint. So
It's an easy target.
Yeah.
Okay. So viewers, thank you for sticking around. We appreciate your patience. This is the best part of doing this stuff live, chaos. If you like this session, go mash that YouTube like button. And don't forget that you can subscribe to youtube.com/inclusivedesign24 to be kept in the loop on our future events. Inclusive Design is brought to you with thanks to our supporters, Google, Intopia, Barrier Break, Tetralogical, Intuit, InfoAxia, and the law office of Lainey Feingold. Inclusive Design 24 will be back on the hour with our next session featuring Lainey Feingold.